Hello everyone. Today we're going to look at Unit 5, Lesson 3, solving quadratics using any method. So we've talked lots about solving quadratics and how when we are solving a quadratic, we are trying to find the zeros, the roots, the x-intercepts, the solutions, right? All those words mean the same thing. So whenever you're trying to solve a quadratic, you're trying to find the zeros. So we've already spent lots of time talking about that we could factor to find our solutions. In the previous day's lesson, we introduced the quadratic formula. So today we're going to look at a few examples and try to decide, should I factor it? If it's not factorable, then I'm going to use the quadratic formula. So always check for factors first. So here's the first example, a squared plus 7a minus 30. We should always look for a common factor first, and since this is a simple trinomial, we won't have a common factor. But then we should try SPF. So we'll set up our SPF. We need two factors that add to a positive 7 and multiply to a negative 30. So two numbers that are going to multiply to 30 but add to 7. It's going to be a positive 10 and a negative 3. So we'll put those factors in our bracket. So we'll have a plus 10 and a minus 3 equals 0. So then our solutions come from setting each of our brackets equal to 0 and solving for the variable. So we can say, therefore, the solutions, okay, a equals negative 10, a equals positive 3. So those are the solutions to that quadratic formula or quadratic equation. We'll look at the next one. Again, we check for a common factor. I don't see a common factor for 2, 5, and 8, so we have a complex trinomial. We'll try to set up SPF again. So I need two numbers that add to a positive 5, but this time multiply to 16, because our A is 2 and our C is 8, so 2 times 8 is 16. If we list our pairs of 16, we have 1 times 16, 2 times 8, and 4 times 4. Oops, 4 plus 4, 4 times 4. Okay, I don't see any of those factor pairs that will work to add to 5 but multiply to 16. So there's no factors. So I'll just say no match for what we're trying to do. So in that case, we're going to use the quadratic formula. This is a good time to mention as well that for those that maybe aren't a big fan of factoring, if you have a hard time deciding whether or not something factors, you can always use the quadratic formula. Okay, you can always go ahead and try to use that quadratic formula, and that will give you the answer. So remember, this is A, this is B, and this is C. So if we sub into our quadratic formula, we're going to have x equals a negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a, which is 2. Okay, so we'll have a negative 5 plus or minus. Under that square root sign, we're going to have 25 minus 64. Hopefully we can see what's going to happen over 4. And then we'll have negative 5 plus or minus the square root of negative 39 over 4. Okay, you can't have a negative under your square root, right? You can't square root a negative. So that means, therefore, there are no solutions to this quadratic. Right? Will not factor. Okay, let's take a look at that next one. See if we can get it to work. So sometimes we might factor and realize it's not possible, or try to factor. Sometimes we might use the quadratic formula and just realize, oh, there's not actually any solutions for this. And that tells us that the graph of that quadratic won't cross our x-intercept at all, or x-axis at all. So the first thing we're going to do with this next one is we're going to rearrange to standard form, because we need everything on one side of the equation before we can factor or before we can use the quadratic formula. So we have 7x squared. We'll minus that 2x to the left and minus 1. Okay, so I'm going to try to set up my SPF. I don't see any common factors. I need two numbers that add to a negative 2 and multiply to a negative 7. Well, my only factors of 7 are 1 and 7. And there's no way we're going to get those to add to negative 2. So we can say there are no factors that work. So we're going to use the quadratic formula. Okay, so if we were to label our A, our B, and our C, we know A equals 7, B equals negative 2, and C equals negative 1. Take a minute, pause your video, and see if you can plug those into the quadratic formula to find your solutions. So if you plug into the quadratic formula, you should end up with solutions. So we'll say therefore the solutions are x equals 0.55 or x equals negative 0.26. We'll try one more. So again, we need to get everything on one side of the equation. So it's usually helpful if our y squared term is positive. So let's rearrange with a positive first term. So in order to make my first term or my y squared term positive, I'm going to move everything to the right hand side of the equation. So I'm going to have 0 on the left, and we're going to have 10y squared. We'll minus the 32y over, and the plus 6 just stayed there. Okay, I'm just going to rewrite this with my 0 on the other side because that's how we're used to kind of seeing it. And then we factor the way we know how to factor. So first, we should be able to common factor. I see that I have a bunch of even numbers, so we should be able to common factor out at least a 2. That looks like the greatest common factor. So we'll have 5y squared minus 16y plus 3 equals 0. Okay, and now we have a complex trinomial, so we'll use decomposition. So if I set up my SPF, I need two numbers that are going to add to a negative 16 but multiply to a positive 15. This is looking more feasible. So my factors of 15 are going to be 1 and 15, 3 and 5. So if we had a negative 1 and a negative 15, that'll add to a negative 16 but multiply to a positive 5. So we will use those to do decomposition. So we'll have minus 15y minus 1y plus 3 equals 0. And then going back to our rules for decomposition, we will common factor out of our first two terms and common factor out of our last two terms. So from 5y squared minus 15y, I can common factor a 5y, and I'm left with y minus 3. And my last two terms, I can common factor out a 1, which again leaves me with y minus 3. And then if I pull out my common bracket of y minus 3, I'm left with 5y minus 1. Okay, so once we have them in our brackets, we should be able to then find our solutions. So we'll set our brackets equal to 0 and solve. So one solution would be positive 3, and then for this one we would add 1 and then divide by 5. So we could say therefore the solutions are y equals 3 or y equals 1/5. Okay, So always looking for, can I factor a quadratic? If I can't factor it, I'm going to use the quadratic formula. Okay, let's take a look at a word problem as it relates to setting up a quadratic equation and then using the appropriate strategy to solve. So it says, find 3 consecutive positive every other integers. That's a lot of kind of jargon there. So find 3 consecutive positive every other integers. So when I think every other, we should be thinking we're going up by 2. So they're either going to be positive even numbers or positive odd numbers. So when you see here in brackets it says 1, 3, 5, that means like if we start at 1 and we're going every other, we're going to add 2 or add 4, right, from where we started. The same is true if we were talking about even numbers. So if I started at 2, I would add 2 or add 4. Right, and then add 6, add 8, and so on and so on. So we're trying to come up with these 3 positive every other numbers such that the sum of the squares of the first 2 terms, okay, the sum of the squares of the first 2 terms is 15, actually I'm going to use a different color, is 15 less than the square of the third. So let's pretend that we just had 3 numbers we're trying to find. Okay, we have number 1, number 2, and number 3. We don't know what these numbers are right now, okay? It says the sum of the squares of the first 2. Okay, so my first 2 numbers are 1 and 2. It's telling me to sum the square of them. Well, if I'm squaring them, that means I'm raising them to a power of 2. So the sum of the square of the first 2. Okay, so that takes care of that green. And then it says is. When we see is, we should be thinking equals, right? So everything we just did there with the sum of the squares is going to be equal to something. Okay, it's going to be equal to 15 less than the square of the third. Okay, well 15 less than my third number . 15 less, but it says the square of my third number. So I'm going to, again, square my third number and then write it minus 15. So that gives me an idea of what I'm trying to do with this word problem. But we need to give some variables to our numbers. We can't just call them number 1, number 2, and number 3. So let's say number 1, we're going to let x represent the smallest integer. And for our number 2, well, like we set up here, our second number is going to be generated by adding 2 to our first number. So we're going to let x plus 2 represent the second number. And then hopefully we can see where this is going. So for number 3, we're going to let x plus 4, not plus 3, x plus 4 represent the third number. And then we're gonna put in these little algebraic expressions into this equation that we've basically created up here. So instead of using number 1, number 2, and number 3, we're going to use these variables we've assigned to it. So instead of using a number 1, we're going to say x squared. Instead of saying number 2, we'll say x plus 2 squared. And that's going to be equal to x plus 4, which is my third number squared, minus 15. So now we've created this algebraic equation that we can try to solve. Okay, before we try to solve it, we're going to expand and simplify to see if this starts to look like something that we know how to work with. So let's expand and simplify. So that's going to require us to do some FOILing. So we'll have x squared. And if we have x plus 2 squared, we know that that represents that bracket being multiplied by itself, just like this x plus 4 squared. So we will FOIL those 2 sets of brackets. So when we FOIL x plus 2 times x plus 2, we should get x squared plus 2x plus 2x plus 4. And then we can FOIL the other side. So we'll have x squared plus 4x plus 4x plus 16. And then we still have that minus 15. Okay, so we should we should try to simplify as much as we can before we start moving things. So let's simplify everything on the left. So if we have an x squared and an x squared, that's going to be 2x squared. We have 2x plus 2x is 4x. We have plus 4. On the right-hand side, we only have 1x squared, but then we have 4x and 4x, so that's 8x. And then we have 16 minus 15, which is a plus 1. So now we've simplified as much as we can. Based on what we did on the first page of our note, we need to get this in standard form. And then once it's in standard form, we should be able to solve by factoring or using our quadratic equation. So let's move everything over to one side. So if I move my x squared over, it's going to be 2x squared minus x squared, so that's just x squared. And we'll have 4x minus 8x, so that's going to be a minus 4x. And then we'll have 4 minus 1, which is plus 3. So now that long algebraic equation, we've boiled down to just a simple trinomial. So nothing to common factor. Let's see if we can factor using SPF though. So two numbers that add to a negative 4, but multiply to a positive 3. Okay, that's going to be a negative 3 and a negative 1. So we'll factor this to x minus 3 and x minus 1. So that tells me my solutions are x equals 3 or x is going to equal 1. Well, remember, it's asking us to come up with 3 consecutive numbers. So we have to find 3 of them. So we have basically 2 solutions to choose from. We have that x can equal 3 or x can equal 1. So if we were to come up with our second and our third number, we know that this represents number 1. We need number 2 and number 3. Okay, so our second number was x plus 2, so that's going to equal 5. And our third number was x plus 4, which would be 7. Or if x ended up equaling 1, then x plus 2 would be 3, and x plus 4 would be 5. So we could say, therefore, the 3 consecutive integers are either 1, 3, 5, or, because remember we had 2 solutions, 3, 5, and 7. Okay, so a word problem that seemed very, very complicated, we were able to set up an algebraic equation and expand and then simplify it to a very simple trinomial that we could find the solutions for. Okay, that's all for your note for today.